Hello, and welcome to Group 10's Mechanical Dissection video presentation. This presentation is a collaboration of its members Stephen Williams, William Wheeler, Joe Wolf, and Braden Grinnell. Let's get started. This video presentation will discuss the mechanical dissection of an Oral-B mechanical toothbrush. An automated toothbrush was taken apart and observed where key components and functions within the device were inspected. Through this inspection, this presentation will cover the current design of the toothbrush as well as its functionality. The current design will include a complete system discussion as well as an accompanying visual aid. Customer requirements along with a discussion including a house of quality and specification sheet will be given. Lastly, information and ideas for design improvements will be presented for future endeavors. The mechanical toothbrush has no clear indicators on how the device is operated, although it is quite simple to figure out. The top section rotates back and forth while the bottom section oscillates up and down by a rotating shaft. This metal shaft rotates simultaneously to operate both components of the toothbrush head. The brush head is removable and is accomplished by pushing in a tab located on the neck of the toothbrush. The functionality of removing the brush head is to allow for immediate replacement for future use and is indicated on the packaging. The toothbrush is powered by a battery within the battery dock, and placement of the battery is indicated with an image within the dock. The subassembly was removed by flexing the toothbrush to disengage two snaps and then sliding the subassembly out. The snaps are positioned to allow the most ease in flexing the shaft for removal. A rocker switch is used to engage and disengage the power supply. When the rocker switch is removed, the device has continuous operation. This is because the stop that was blocking the battery was removed. A hollowed-out rotating cylinder couples with the main metal shaft in order to cause brush head movement. The hollow in the cylinder is offset in order to cause this rotation. In order to give a concise description of the customer requirements, we can use a house of quality for the product. These requirements include an ability to effectively clean teeth, ease of operation, comfort, cost effectiveness, energy efficiency, being compact, aesthetically pleasing, as well as a safe design. Some of the major functional requirements include wireless assembly, a battery dock, motor, plastic body, contoured design, rubber grips, openings for drainage, and a rocker switch. Another way to address key customer requirements and specifications is to construct a specification sheet. As a group, there were many attributes to consider, with some being more vital than others. Labeled above, a D represents a demand which is more crucial to the design than the specifications marked W for wish. Some of the key demands are on-off switches, draining holes, rotating bristles, being waterproof, a brushed DDC motor, and oscillating metal shaft. Some of the notable wishes for the design specifications include rubber grips, easy assembly and disassembly, long battery life, and interchangeable bristle heads. Although the concept of mechanical and automated toothbrushes isn't a groundbreaking or revolutionary idea, there are many design improvements that can still be accomplished. Through the group's thorough understanding of customer requirements, there are a few changes that can be made to improve overall manufacturability, aesthetics, and functionality. Easier head detachment can increase the longevity of the product because overly rigid body components can lead to destruction and malfunction of the toothbrush. Better indicators and a quieter operation will also help ensure customer satisfaction. Lastly, having a rechargeable battery and increased durability is paramount in the success of a brand. as quality and dependability yields a more confident brand name. Thank you. This concludes our video presentation.